Okay, so hello everybody. Um, in this video, we are going to learn about the permutation and combination. We are referring the prembron for this. Okay, so this is the book, the prembron. We are referring chapter 5, the permutation and combination, right? When we learn about permutation and combination, right, where it comes from. So when starting this, okay, it so good morning. Where this permutation and combination comes from, right? So it comes from the chapter 4, section 4.4, and you should be able to recognize and calculate conditional probabilities. What is conditional probability? So let's check. There are conditional probabilities. Basically, you have learned in 4.4, right? Chapter. There are some simple situations with a millions of probability possibilities, right? So this topic is concerned with selections and arrangement of objects. Permutation and combinations appear in many complex modern applications, right? May it be your transportation logistics, okay, relationships between proteins in genetic engineering, right? So it's a field of biotechnology there. Sorting algorithms in computer sciences and protecting computer passwords. So basically, when you put a password, it gets encrypted into another form, and then you have play with probabilities and all of this to decode it, right? So something like this. It also used in e-commerce transaction in cryptography. Okay, a selection of an object. So what is this basically? So if I do this, a selection of an object is called a combination, and if the order of the selection does not matter, however, if the order of the selection matters, it is called as a permutation. Okay, so there are two things here to know, and that is when we just select an object, okay, we just select an object like this, it is known as a combination. But if if the order of the selection matters, it is known as a permutation there. Okay, so what is the difference between permutation and a combination is clear? Yes. Let's say we are taking A, B, C, three things. Okay, and in these three things, we want to know what of the ways I can combine these things. This is A, this is B, and this is C. So can we just know in how many ways can I combine this A, B, C, right? So yes, we can combine this A, B, C in the groups of two, right? In the groups of two, I can combine this three in the way like A and B, A and C, and B and A. Correct? That's it. Okay, let's see. So if I talk about combinations, how many combinations are possible between this, right? So you may say A and B. Okay, you may say B and C, and the third one you may say A and C. Only three this combination. This is known as a combination, right? The first one we are talking about. But when the order also matters, right? Let's say if I in this same thing, if I want to know what is the and how many cases, how orders I can arrange this. So it can be A B, it can be B C, it can be A C. Okay, these are the three basic combinations, right? In the next one, I can just rearrange this to form like B A, C B, and C A. So now the same combinations, although the combinations of AB and BA are same, right? But the sequence matters, right? A comes first and B comes second, or B comes first and A comes second. That is very important in this. And the second one is known as a permutation, right? There is a very good example given of an Enigma encrypting machine, right? We can actually have a combination of that, right? But to use this, right, in this chapter, we'll frequently need one thing, and that thing is known as a factorial function. Okay, what is a factorial function? It's basically a shorthand method of writing permutations, right? On most of the calculators, you may find something like this, an exclamation mark type thing. Okay, that is known as a permutation. Okay, just see this. So if I say, what is 4 factorial? What it basically means, If I write a 4 factorial, it basically means a 4 into 3 into 2 into 1. Okay, that's it. Now, is this clear till here? Now, we would just quickly see what is one of the points which a factorial is. So in general case, if I want to represent a factorial, it would be as simple as, let's say I'm taking a factorial of a number n, okay, where n is any whole number, a natural number, right? So n factorial in this case would be n minus 1. Here it's a multiplication between, right? Multiplied by n minus 2, multiplied by n minus 3, and it will go on so, okay? It will go on till it gets 3 into 2 into 1, and it ends at 1. So any factorial, it just goes in the reverse order, right, till it goes to 1. That's it. There is one more important thing to note, and that is 0 factorial. So what about 0? We have to just know this, that 0 factorial is actually, we have a proof for this. 0 factorial is nothing, 0 into, okay, this is represented by 1. This is the thing, 0 factorial is represented by 1. Now there is a proof for it, okay, and we may know this. Okay, so now we are going to start with something of what are the following ways. Okay, so there is one exercise given in this. I would just take a gist of it. So now we are heading towards exercise 5A of the prembron, right? This is the exercise. How will you do this? Okay, now without using a calculator, find the value of 5 epsilon upon 3 epsilon. So just take normally what is 5 epsilon, what is 3 epsilon, and we will divide it by, and we will get the common things, right? So generally, let's start with this, right? What is 5 epsilon here? 5 is epsilon is basically 5 into 4 into 3 into 2 into 1, correct? What is 3 epsilon here? It's actually 3 into 2 into 1. If I go on dividing both of these, right, here, so these all the things will get cancelled. 3 into 2 into 1, 3 into 2 into 1 will get cancelled. So a better way of representing is this. Just see which is the what is in the denominator. If the denominator is less than the numerator, right, then you just go till that number. For example, 5 epsilon upon 3 epsilon can be also written as 5 into 4 into 3 epsilon. Because after that it is just 3 epsilon falling out there upon 3 epsilon. So in this case, both of these 3 epsilons and 3 epsilon will cancel out, and whatever is left is your answer, right? So this 3 epsilon will cancel out to give you a 20. Okay, that is the answer for the first one. Let's see the second one. 4 epsilon upon 2 epsilon minus 3 epsilon. How would you do this? So you would do this way. 4 into 3 into 2 epsilon upon 2 epsilon minus, what is 3 epsilon here? So you would get as 3 into 2 into 1. That's the way. So you just cancel out this. You're left with a 12 and a 6 here. Your answer is straight away 6. That's it. Okay. Now, just see this part C. How to do this? So just wait a minute. When we going to part C, just see it is all about 7 into 4 epsilon plus 21 into 3 epsilon. Now, if you see this, there are two methods of doing this. Either you do it directly, manually, or you take something common out. When I see this, I can get, let's see, 7 into 4 into 3 epsilon plus 21 is actually 7 into 3 into 3 epsilon. So out of this, to make my calculation easier, because I am, of course, doing this with a non-calculator, right? It's a non-calculator sum. So what I can do is, I can take this 7 common. I can take this 3 epsilon common from both of them. So my next step would be something like this. 7 into 3 epsilon. I'm left with 4 plus 3. Now, this would give me a 7 epsilon into 3 epsilon. That is 3 epsilon is 6. 7 6 are 42, 42 and 7. Which I can directly tell as it's 281. So it's 294. That's it. Okay. Now, once we're done with this, let's go to the part D of this one. Coming to part D, it is as simple as this one. You're just seeing it is 10 epsilon. 10 epsilon is actually 10 into 9 into 8 epsilon. Correct? And it is divided by 8 epsilon. You add a 9 epsilon, which is actually 9 into 8 into 7 epsilon. Sorry, factorial. Okay, sorry. By the whole time I'm telling it's actually factorial into 8 factorial. You cut it down and you're left with this. So it's 90 plus 8 into 9 is 72. You're left with 162. That's now. And talking about the last one. So it's this one is 20 factorial into 19 into 18 factorial here. This is 18 factorial and it is subtracted here with a 13 upon 11 factorial, right? 13 factorial upon 11 factorial. This taking it apart. Okay, sorry, I got to know in the mid video it's actually not factorial. It's not epsilon, it's factorial. My bad. 12 into 11 and this is 11 factorial. What you do is you just cancel out the common parts and this is what you're left with. Just 20 into 19, that is 380 into 12 into 13. Okay, so you can just have it. You can always calculate what is 130 and 26, 156. Subtract it and hooray, you will get your answer. Okay, now the thing is, they have done till here, right? You have to just practice in order to get your answers correct here. Yes. Okay. So I'm just writing this final answer. This is 226. Okay. This is the without calci sum. So you have to calculate everything by yourself. Yes. Now we shall go to the next question. This part. This is what was all about the question number 1 of the prembron 5A, right? Now we will use, we move to the second question of it that says that use a calculator to find the smallest n value for which. Now there are 3 questions here. Something like this. So use a calculator to find the smallest value of n for which. Then this one, you would use a hit and trial method. Now what is a hit and trial method? Basically, you will try to put in values and know that which value will give you around this, right? Because of course, you cannot calculate every value of factorials. But yes, of course, if you have a calculator, the things get easier. So in your calculator, when you do this, you will get a value that a 9 factorial is actually a number which is slightly less than 10,000. This is 10 to the power 6, right? And 10 factorial is greater than 10 to the power 6 when you find the values. On getting that, you will get that actually 9 is a number, n is a number that is 10. So the smallest possible value of 10. Now remember, why we are writing smallest possible? Because it can be possible that it would be 11 factorial, 12 factorial, all these numbers after 10, right? Including 10. So 10, if I draw this, so after 10, this is 10, right? 10 factorial is actually greater than 10 to the power 6. So all the numbers after 10 factorial would be actually greater than this. So they are always talking about the smallest value of n, right? The smallest n would be 10. See the second one. Here, they're talking about 5 factorial into 6 factorial. Now, 5 factorial into 6 factorial, when you see the value, right, it would be actually 86400. You can check in your calculators. So what is actually asking about is this value should be less than n factorial. Okay. Now, 8 factorial, if you see, is less than 86400. You can check in your calculator, and which in turn is actually less than 9 factorial. So again, what is the smallest value of n here? The smallest value of n here is 9 factorial. Right? But this being said, can you just guess that answer for the C1? Yes? Yes, it is simple enough. If you just see the C1 again, it is the same thing. You are actually doing a factorial of factorial, right? So let's say, okay, what is the example? How would you solve this? So let's say 3 factorial is 6. What is the 6 factorial? Right? So 3 factorial is 6. 6 factorial is 720. Right? Now 720 is actually less than 10 to the power 20. Okay. You want a number which is more than 10 to the power 20. Correct? So let's try another number. Let's take 4. So 4 factorial is actually 4 factorial is 24. What is 24 factorial? Now, this is a big number, a very big number. So 24 factorial is less than 10 to the power 20. So the smallest number, again, I would say, you know the reason why we are talking only about the smallest number? So the smallest number, the smallest value of n, which would I say, is 4. Is it clear? Yes, so this is the answer for the second one. Let's take the third one here. The third one says, the question number 3. Okay. Third question says, use the smallest value. Okay, use a calculator to find the largest value of n for which this is possible. Now, you may ask why this is talking about the largest value. So if you see clearly, the n here is in the numerator. Okay, so let's try to find it out. What is the method and that they are using here. So talking about the first sum, right? If you see here, n factorial is less than 80 into, this is 5 into 10 to the power 5. Okay, if you just multiply all of this, you would get something like n should be less than, so n factorial should be less than, it's 4, 5 into 4, it's 40, correct? So it's 400, and it's already 10 to the power 5. Okay, so I would, in the standard form, I would say that n to the factorial should be actually less than, you can represent by this way or by the standard form, right? Now, it should be strictly less than which number? It should be less than this number, right? And you want the largest value. Now you understood why the largest value? Because you are talking about a value of n that is fairly large enough, but you have defined an upper bound for it. And if you remember in the last question, you were talking about the lower bounds. Now we are just defining about the upper bounds. So what is the upper bound for this n? Let's see. If I just see this, your n, if I just do in the calculator, your n is fairly close to 12 epsilon, right? 12 factorial, sorry. So the largest value of n can be is 12. It's not 12, sorry, it's 11. Because 12 is a number which is actually greater than this. 4 to the power 7. 4 into 10 to the power 7. 12 is greater than this. And 11 is a number which is slightly lower than this. Right? Okay. Now, when we talk about sum number B, how it works, okay, it works fairly the same way almost. Right? Just see this. In this one, what is happening here? You are saying your value of n should be n factorial should be less than 1.5 into 10 to the power 12. Correct? Now, if you just see this here, that you will calculate and you will know that 15 factorial is less than 1.5 into 10 to the power 12, which in turn is less than 16 factorial. So your number, this number that we have 1.5 into 10 to the power 12 is actually somewhere lying between the 15 factorial and the 16 factorial. So what is the largest value of n? So the largest value of n that we get here is 15. Okay, that is the largest value of nu. Now, coming back to the third question here. Okay, this is the third question. And when we talk about this, just see this is talking about n factorial upon n minus 2. Okay, so let's use the first let's simplify this and see what is the factorial n factorial actually. So n factorial is n minus 1, n minus 2 factorial, right? In this way, we can simplify this fraction first. And we got this as n factorial, and n minus 2 and n minus 2 will get cancelled out. Here. After cancelling, we are left with something like n minus 1 should be less than 500. Now, you can actually use the calculator and you can get what should be the value of n here, right? Or you can use a quadratic equation like n square minus n minus 500, okay, should be less than 0. You can solve this quadratic equation to get a value. So there are two ways. Either ways, you will get something like this. 22 into 21 is actually less than 500. Okay, which in turn is less than 23 into 22. So we are talking about the largest value of n, correct? This is the largest value of n. So the largest value of n is 22. That is the answer for this one. Okay. Now, moving to the next part, what is this is the answers for all three of these, right? Now, what is the next question? The next question says something like this. It talks about express and as many as ways possible 144252. So this is a number given, and these are the two numbers, and the third number is 1.5 in the form of a. So I've just, it's not visible here. It's a factorial multiplied by b factorial upon c factorial, where none of the a, b, and c's are equal to 0 and 1. Of course, this is the way to stop you from making things simpler, right? Like if you can just avoid it by just making zeros and 1 there. Now, just see here, what is happening here? It is 114, correct? How do you proceed with the sum like this? Okay, is there a way? Yes, of course. 112, as you know, okay, there are many ways of representing it. It's 12 into 12, correct? If I just wanted to find 12 into 12, there are another way. Okay, let's say just representing it by in the form of 3 into 4 into 12. right? Or any other form like this. So we can represent it by 9 into 16, right? If I want to find a 9 into 16, how would I found this? Yes, 16, if you know, is nothing. 16 is 9 into 8 into 2, correct? So is there a way to find it out? Yes, exactly. We found it out something. See, this is 9 into 8, correct? I want to make this 9 into 8 in the form of a factorial. Can you think about it? We have seen something here like this, right? 5 factorial upon 3 factorial. So we will get 5 into 4. So our main goal here is to find something consecutive, right? That would help us. We already found it out. And there is the final step. So to find 9 into 8, what will we do is actually we take something like 9 factorial upon 7 factorial. Why 7? Because 9 factorial is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. At 7, when I divide it by 7, we are stopping the factorial at 7 itself. And of course, because there is a 2 there, we would just multiply it by 2 factorial. So see, here we have achieved a form which is actually a factorial, b factorial, and c factorial. We have also satisfied the condition that all of the a, b, and c's are unique. And apart from that, none of them is equal to 0 or 1. This is one of the solutions. Now, an important thing to note here is there are many solutions to this type of questions, right? And you may find more than one solutions. All of the solutions can be correct, right? What you need to check is always cross-check the answer from this question itself, right? So another solution which students generally found is 72 factorial multiplied by 2 factorial upon 71 factorial. Now this is fairly simple enough because 9 into 8 is 72. So you just want that number 72. Okay. And you would get 72 upon 71 factorial. You will divide and you will get the final answer. Right? Now, in another case, let's see what is happening. The other case is about the number 252. Correct? What will happen in 252? Can you just factorize? So what is the goal is? First factorize 252 in the way it is possible. Right? And see what are the ways you can get 252. Right? There are many ways of getting this, but let's see. So if I just do 252 here, 252 is actually 126 multiplied by 2, correct? Is it? So we get one of the answers as, let's say 126 factorial multiplied by 2 factorial upon 125 factorial. Yes, this is one of the answers. Can we simplify it? Of course, why not? So if we just do this, if we just clearly see this, 252 is what, right? Can we say it is 7 into 6 here? And this thing is actually here, more 6, 7 into 6 into 6, right? The whole thing, 252, right? So we can always apply this. 7 into 6 is nothing. We can apply 7 factorial upon 5 factorial. To compensate for the 6, right? 6 is nothing. You already know 6 is 3 factorial. So by using this, we got two of the answers. This can also be a possible answer for this. And this itself is also a possible answer for this, right? This is, of course, the easier one. And if you just factorize it more, you will get this one. Yes, in this case. Now comes the interesting part of 1.5, right? Now this is a mixed fraction. If you just see this thing, this is a mixed fraction here. What is important here is to first simplify this, because we cannot, of course, it would be difficult to solve in this pattern. So we would simplify this one and solve it. So what is the simplified form of 1 by 2, right? It is 1 by 2 is actually 3 by 2, correct? How you get 3 by 2, right? You means 3 in the numerator and 2 in the denominator. There are various ways of finding it, right? let's say one of the way is 15 factorial multiplied by 16 factorial. So what is 15 multiplied by 16? It's 1 by 16, correct? 1 by 16 is then, so if I want to make 1 by 16 into 3 by 2, right, what would I do? I would just multiply it by 4 factorial, because 4 factorial is 24. So 1 by 16 into 24, and just divide it, and you will get 3 by 2. As simple as that. This is one of the way. Is there any other way? Yes. As I said, this questions has a lot more, like it can has many ways to solve this. So I may say that is 15 factorial upon 4 factorial upon 16 factorial, but there is another way, let's say 679 factorial. But this is a fairly big number, okay, upon 5 factorial into 80 factorial. And this one, exactly the same thing is happening. See, 79 and 80 is actually less, only it has a difference of 1. So you would get something like this, okay, like 1 by 80 multiplied by 5 factorial is 120. So you just cut this and you would get something like 3 by 2. Okay, so this is another way of doing this. Of course, there are many other ways in which you can achieve a 3 by 2 combination. Okay, so moving on to the next type of question. So this was one of the type of the question that was given in the prembron, right? Now, moving on to the next type of the question is this one. Question number 5, which is a simple question, and that says express the area 53, 52. Okay, so just wait a minute. This is saying express the area 52 and 53 centimeter of a rectangle. So what is the area of a rectangle? It's length into breadth, correct? So 52 and 53 is the area of the rectangle itself. I want to represent this thing in the form of a factorial. How would I represent this? So 53 into 52. Now, I don't want 51 here. So what I do? I would divide this whole thing by 51 factorial and multiply it by 51 factorial, right? To get something like 53 factorial upon 51 factorial. This was as simple as that. So when we expand this 53 factorial, you would get a 52, 52. So basically, we are reversing the process, right? We are in this, the whole aim of this exercise is just to learn how factorial works. Okay, because in the further upcoming exercises, you would need this. Okay, how factorial, the basic structure of factorial is working, right? Moving on to the question number 6. Two cuboidal boxes measure 25 centimeter by 24 centimeter into 23 centimeter. Now, just note this. All of this number are consecutive numbers, right? And 8 into 7 into 6. Express the differences between their volumes using factorial. So when we see this question also, it is the same thing. I want to find the difference between the volumes. Okay, I want to find the difference between the volumes. Now, you already know what is the volume of a cube. A volume of a cube void, okay, is length into breadth into height. Means you multiply all the dimensions together. So let's say the volume of the first cuboid, the bigger one, minus the volume of the second, is 25 into 24 into 23. Okay, and this would be subtracted by 8 into 7 into 6. Now you have to not find the volume. That's the important part. Okay, that is just a calculation, simple calculation. You have to express this volume in terms of factorial. Now see, 25 is there, 24 is there, 23 is there. What is not there is 22, correct? So you would divide 25 factorial by 22 factorial. That's it. It's as simple as that. Now, see here again, so 8 is there. So it would be 8 factorial. And which number is not there? So as you can see, 8 is there, 7 is there, 6 is there, but the consecutive number 5 is not there. So you divide by a number 5 factorial, right? On doing this, this is the final answer. So you just whole bracket it and say this is a difference expressed in factorials, right? Now, just see this type of sum. The last sum of this exercise is on question number 7, which says, okay, just wait a minute. This is the question number 7 in front of you. 8 children each have 7 boxes of 6 eggs, and each egg is worth $0.09. Right? Now, write the total value of all of these eggs in the dollars using factorials. How would this sum comes as, right? So first of all, keep a habit of tracking the data. This is 8 children, this is 7 boxes, and this is 6. And they're talking about each one of them. So you would get something like 8 children into 7 boxes into 6 eggs. These are the total number of eggs, correct? And what is the cost of each egg? That is $0.09, correct? Yes. So you would get something as $30.24, right? But is this the thing that they're wanting? No, they're wanting the answer in factorial, of course, because this is an exercise in which they're focusing on how factorial works, right? So see this, you have 8 here, you have 9 here, 7 here, you have 6 here. Of course, you have a 9 also here, but let's just focus on this part, right? So for this part, I would say first just deal with one of the parts. I would just like to have dealing with this part here. How to deal with this one? 8 into 7 into 6, right? So what you do is you do 8 factorial upon which number is not there in the consecutive, right? It is 5 factorial. So you would just divide 8 factorial into 5 factorial. You will multiply this. Just see this number. What is this number? This is actually 0.09. 0.09 can be expressed as 9 upon 100, right? Then this is not a factorial. You have to represent 9 upon 100 in a form of a factorial, correct? Now, just see this. This is 9 factorial and this is 8 factorial. Okay, now this is a rough work here. 9 into 8 factorial can be written as 9 factorial, right? Is it clear? Okay. So we have sorted the numerator here. It would be 9 factorial. What about the denominator? We want 1 upon 100 to be expressed as a factorial. Is this a way? Yes, of course. 99 factorial divided by 100 factorial. If you do this, every number after including 99 would be cancelled out in the denominator. And you're left with only 1 upon 100. And that's it. So I would end up this question in the form of, let's say in the simplest form, this is 99, okay? 9 factorial upon 5 factorial, that's the original one. And to make the 100, right, I would multiply this by 99 factorial by 100 factorial. Now, of course, as I said, this is just one of the ways that you are doing this, right? You may have your own unique answer based on the way how you break these numbers, how you perceive this number. And this is the beauty of maths, that the more you see this, right, you can have more and more ideas of doing this, right? So there are another ideas. Many children come to me with examples like this. So can't this be described as 6 factorial plus 3 factorial into 3 factorial, okay, divided by 4 factorial plus 1 factorial. There is someone coming to me with an answer like this also, right? Like, can it be described like 9 factorial, which is of course our numerator, divided by 5 factorial into 5 factorial minus 4 factorial, okay, plus 2 factorial plus 2 factorial. Now this is a very big answer, right? These are other two ways which it can be represented. But of course, when I told all these 3 answers, okay, are unique, and all these 3 answers are the ways in which this can be represented. So none of the answers are correct. None of the answers are wrong here. Sorry. It's just the way, it's just the freedom that the mathematics gives us while writing our answers, right? So With that being said, our first exercise of prembron is done, and thank you.